talking about angles. So far in this first chapter, we talked about all segments. We talked about, well, first of all, we talked about defining things, like points, lines, planes. What does a line look like? What's a ray look like? What does opposite rays do? What is a plane? All that kind of stuff. And then we started talking about segments. When we talked about segments, we said that you can, remember we said from the front to the back was what, 12 squares, I think? If I go 3 squares, how much more do I have to go? 9 more. So you made a good mistake, you caught it, and you were okay. But the idea was is that you could add 2 segments together to equal a larger one. Now, were those 2 segments always the same length? Could they be? Yeah. Now, all those things and ideas with segments, if you go back to thinking about them, when we did segments, one of the things that we've talked about was this thing called segment addition. Remember that? And when you did that segment addition, you basically had something like this. When 3 points are on the same line, what are they called? Collinear, very good. So when you had 3 points that are on the same line, we called them collinear. And that in turn meant if this was W, X, and Y, what are the 2 smaller segments that add up to equal the larger? Very good. I know that I can say via this diagram that WX plus XY have to equal WY. Very good. Now, is there anything in this diagram that tells you that WX is equal to XY? If they were equal, what would they have to have? The tick marks. Remember tick marks? These tick marks denote that they're equal. They're congruent. Okay, that's that fancy term we use for that. So what we're doing today is we're talking about basically the same thing, but we have angles. All right? Now, if you think about it, let's see if I can do this. Line, right? Segment? Let's see if this will work. Oh, never mind. Won't work. Anyway, we'll go back to the other one. Angles are just 2 different rays that share the same endpoint. Remember a ray had an endpoint that went through another point in some direction? That's all an angle is. An angle is just 2 rays connected with the same endpoint. One of the things we defined last week was a thing called opposite rays. Opposite rays had that common endpoint. Rays go in other directions. They created a segment, didn't they? Or a line, excuse me, because they were continuous. Now, if I turn that opposite ray a little bit in any direction, it just makes an angle. Now, when you label these things, and this is one of the things I love to note here for myself to remind us, is that you label these very specifically. Rays have 2 letters, correct? So if I say that this is ray AB and this is ray AC, what is the common endpoint? A. Okay. Do you know what that's called in an angle? That common endpoint? Louder. Vertex, very good. So an angle has what's called a vertex. The vertex is the common endpoint of an angle, or excuse me, the common endpoint of those rays. So as you go through this, remember, we're going to show you guys ways that we label things. When we labeled segments, point A to point B, point B to point A, it didn't matter which way you went because it was the same segment length. When we labeled rays, did the lettering matter for a ray? Yes, the lettering mattered because you had an endpoint and it passed through something. Same idea with angles. When we label our angles, we're going to label them with 3 letters. The middle letter will always, always, always be the vertex. Okay? So in this case, I would call this angle. I use an angle symbol. It's a little bit different than what you might see out of a book. I put an angle, and I put this little hook in it, this little arc. I learned that from my high school geometry teacher, Mrs. Bender. She knows Carry Grove. It's weird. It's a small world when you start getting into these things. Yeah. Her mom was my high school science teacher, I think for physics, I want to say my junior year. 1990-ish, one-ish. I started high school in the 80s, so. No. Back in my day, back in my day, this is not a BS statement here. This is not one of those fake ones. That happens. When you guys get to Algebra 2, you guys will study something called the unit circle. If any of you have friends that are in Algebra 2 or have taken it before, you might have seen this. What happens with the unit circle is that you get angles that are placed at the center of the circle. When it's placed at the origin, that means your center is in the middle of the circle there. The angle measure here, whatever this measurement is the exact same thing as the measurement of that arc. So if this angle here measured 20 degrees, the arc measured 20 degrees. So it came from the idea of that the angle equals the arc when it's placed at the center. That's where that symbol came from. Okay? Not that you need to know why I did that, just so when you see me draw that angle symbol, that's what it means. Because if I do just this, the less than symbol, or a really badly drawn L. Because the alligator wants to eat more Twinkies. He wants to eat 3 Twinkies instead of 1. Sorry. Lastly, the last part of the angle are the sides. The sides are the rays that make up the angle. So when we label our angles, we write them out in terms of the 3 letters. The middle letter will always be the vertex. The other 2 letters are the points on the sides. So I can do this one of 2 ways. Angle BAC or angle CAB. Either way, it is fine because it's the same direction. I'm sorry, they're different directions, but they're encompassing the same set of interior points of the angle. Again, extra words you don't need to worry about right now, but middle letter vertex. Okay? You guys have all done things before, right? Once or twice. This. Ooh, I know. So another thing you guys haven't figured out yet is that I like to do autographs. I need somebody to autograph this because in the back wall, when I read the paper every morning when I'm eating breakfast. I'm a junior, and a lot of times what I'll do is, if I see a kid like, oh wait, I think she's in my geometry class, and then I'll take it and I'll throw it in the notes. I need you to autograph this because what we'll do is we'll print it and we'll start hanging on the back wall. If you're ever in my room before, you've seen this. Sorry.
Like right here.
Where do you think would show up better?
I don't. Sorry.
I could mess with her and start moving her name around while she's doing that, but I'm not going to be that mean. Wait, don't go anywhere. So what I want you to do is run out. Do you know where the printer is out in the FTLA? There's a printer out there. Go grab this off of the printer, please. No, just one. I think one year I had Hannah Olberg, Emma Carpenter, and Connor Tierney all like in the same school year, and those 3 kids were in the paper every other day. They had rows of pictures on the wall. Look, another picture. Oh, here we go. Yeah, what is it? I know, it's okay. Does it have to be? There's a post-it, or a little push pin factor going down. Anyway, so what's going to happen today is just like we talked about in segment addition a couple of, like last week, we're going to switch it into what's called angle addition. So when you had segment addition, when you had two segments that were all the same line, you can take the small segment plus the small segment equal the large segment. What do you think changes with angles? Nothing. Very good. Nothing changes. Okay? Absolutely nothing changes. Well, one thing changes. You have extra letters. Segments, you start thinking about it, we only use 2 letters for segments, didn't we? When you start talking about angles, we're going to use 3 letters. So what happens here is these 2 angles, angle ABD and angle DBC, they have a common vertex. Where's the common vertex? The B, good. When you have a common vertex, when you have a common vertex, and a shared side, you can take angle plus angle equals larger angle. Exactly the same thing as saying when we did something that was collinear. When things were collinear, they were all in the same line. Small segment plus small segment equal to larger segment. Here, common vertex, common side. I can say angle plus an angle equals a bigger angle. Instead of getting into all the crazy long-winded words, if we know that we have this common vertex, and I know I have a side that's shared between the 2, angle plus angle equals bigger angle. All right? Lettering, it just looks weird because there's a lot of letters. Here's what it looks like when I write it out in terms of which angles they are. If I look at the first angle, I can say it's angle ABD. What's the next angle? Which one? ABC is the biggest angle. What's the next small angle? Can I say CBD or DBC? Does it matter? If I say angle small angle plus small angle equals big angle. And like I was trying to get at here, guys, is that when you write out in terms of angle addition, you have just a lot more letters. Segments, we had XY plus YZ equals YZ, or XZ. Here I got an angle symbol, 3 letters, plus an angle symbol, 3 letters, equals angle symbol, 3 letters. So what you wind up doing here is you just have to make sure it's written clean. All right? So for those of you with less than perfect handwriting, you'll want to get a little bit more perfect handwriting if possible, just taking your time to write that out. Another thing you can do is this. If this is 32 and this is 46, what's the whole thing? Hey, you did this without a calculator. You did that. I didn't mean to call you out on that one. It's it would just be 78. Now, 32. Do you guys know how what units angles are measured in? Degrees. Angles are measured in degrees. Again, that goes back to the idea of how many degrees are in a circle. 360. There's 360 degrees in a circle, so if I go halfway around a circle, I went how many degrees? 180. If I go half of 180, how many degrees do I go? 90. Okay? That's where all this comes back down to. Now, for geometry purposes, we're going to use everything in terms of degrees. Does that mean when you're done with your answer, you always put that little degree symbol? It'll be okay. I'm going to forget it half the time anyway. It's It's not the end of the world. Okay. On your calculator, did you ever accidentally hit the mode button? And then you see where it changes, it says degree, rad, or it says DEG, rad, and grad. Rad isn't just a movie, recommended. It was this bike movie, BMX bike movie. BMX. It's awesome. Trust me. Pull up the YouTube video while you're in Flex. It's great. But rad stands for radians. Okay? Radians are a unit of measure that normal people use, not just degrees. Radians are what the rest of the world, it's kind of like metric system in like inches. Right? That makes sense. It's like 80-20. Radians are something that you'll deal with in terms of the circumference of a circle, which is in pi. Again, if your calculator gives you a weird value, check your mode. You might have actually, if you ever drop the calculator or somebody resets it, these calculators don't normally do that, but if you're one of those, if you accidentally forget your calculator and you're trying to use somebody's yellow calculator, or the graphing ones, graphing calculators are automatically set to radians. You'd have to change the mode to use any trig functions. Again, it's not going to be a big deal until second semester, but just in the back of your mind, just remember that. Not terrible, is it? All right, let's try it on. Oh no. What do you think we have to do? Math. Very good. Again, when you're doing these things, it's very similar to working with segments. Segments you walk straight across. Here you're just going to turn. You're just turning direction, really. You're doing the exact same steps. I know that I have, according to my diagram, I have a small angle of 35. I have a missing angle of something. But I know that the entire angle has to measure 110. Algebraically, I can say 35 plus something is 110. Which means, what do we do again? Subtract. Subtract it, what do you get? Which means it's 67. Where's your calculator? Don't make silly mistakes with arithmetic. You should never make an arithmetic error. Okay? Arithmetic should be the easiest thing. Will this change if I throw variables at it? No. How many times have we done this semester so far where you have two-step equations? Variables on both sides, anything like that? Just about everything that we've done so far has that same scenario, doesn't it? So do you think the setup's going to change? Nope. For example. Oh, before I get to that, sorry, let me backtrack real quick. What's that symbol mean? 90 degrees, very good, so right angle, excellent. A lot of times in geometry, there's going to be certain things you'll have to infer from a diagram. You know what the word infer means? What? Clue, I guess you assume. This is one of the times you can assume-ish from something. It's when you have diagrams, that symbol means it's 90 degrees. What does that angle measure? 180, very good. That's what you would call a straight angle. We'll talk about the different types of angles tomorrow. But certain things from certain diagrams you can infer information. That symbol means 90 degrees. So what would you do to figure out the missing angle? Excellent. Did you guys hear that? In order to figure out this missing angle here, we know that it's 26 plus something is 90. So you just subtract 26. Okay. I wanted to make sure I showed you that symbol because I think I have one like that. So far, so good? It's going to be okay. You can do it. For example, here's the output I was talking about. Remember how in most cases when we've been talking, that we've always said that, hey, geometry is just like algebra, but you have one more step. And usually that last step is substituting back into the problem to figure out a missing segment, a missing angle, some sort of a value. Excuse me. So here, you are given angle NRQ is 78 degrees. When I look at that diagram, is NRQ a small angle or is it the biggest angle? It's the biggest angle, very good. You're just following the letters to know where they go. Now, when you look at that then, do those two smaller angles share a common vertex? Where? At R. Do they have a common side? What's the ray that they both share? What's the ray that both two small angles share? RP. So that means that I can say the small angle plus the small angle has to equal large angle. Let me move this over just a bit here. So I know that angle. And I'll write this out in lettering. You don't have to if you're fine with this, but I'm just going to show you where this all comes from. It's quite literally writing out in terms of words before you put the math into it. Because now you know exactly where everything needs to go. So angle NRP, 8x plus 7. Angle PRQ, 4x minus 1. Whole thing. There you go. Now, ladies and gentlemen, remember, when you have an algebraic statement and you're combining like terms, you're not moving anything. You're just figuring out what is 8x plus 4x. 12x. What's 7 minus 1? And back to the nice and easy two-step algebra. Excellent. Last but not least. Very good. Sorry, keep you awake. X is. Okay. Now, again, geometry, which means not always just solve for x, it means solve for x and do something with it. Here it tells me to figure out which angle. PRQ. Which means I can go back to my diagram, figure out where angle PRQ is, right here. And I substitute in 4 times 6 minus 1. How much? 24 minus 1. Which is? Perfect. Now, if we math this correctly, when I figure out, if I figure out what NRP is, and I add the two together, I should get 78, shouldn't I? All right, well, just for fun, what's 8 times 6? Add 7 to it, and you get 55 and 23 is? Fun fact, did you know that Sammy Hagar, I can't drive 55, that guy. You've never heard that? Are you kidding me? Anyway, so Sammy, all right, I just not even bothered. No, I was going to say that Sammy Hagar is actually older than Robert Plant. And Robert Plant's the but then you guys, I weep for our future. Not tough, is it, guys? Very straightforward. Okay. I got 4 problems. Yes, I said 4 problems. I know. Oh, woe is you. I forgot what. I think it's 54 or something. What's that? Yeah, that's close enough. I put on the calendar. But here's a textbook if you want to take a picture of it. Page 32, that's close. Oh, real quick, can angles be congruent? Now, when we had segments that are congruent, we used tick marks. When we have angles that are congruent, we still use tick marks, but we don't put them like on the segments themselves. We put a little something like that in the angle itself. That means that those two angles are the same. Mm-hmm. Yep, that's what that means. Okay. So if you see the little tick marks in the vertex area, if those both have one foot, that means each one of those are the same. If one of them has one and the other one has two, they are not the same. So if this one was 36 degrees, what's the other one? 36 degrees, and so on and so on. Okay? You want, I've got a book here if you want to take a picture of it, knock yourselves out. Yes, ma'am. What do you mean? Segments. They can be made up of segments also. In the traditional sense, they're formed by rays, but then if you block them out, they become segments. Like in triangles. Guys, this is a great question. Do angles always have to be rays? No. And the reason being is you start thinking about if these were rays, what if I put endpoints on them and connected them? It makes a triangle, but it makes each one of those sides of the triangle a line, a ray, a segment. What are they? Pretty. Yes, they're pretty. They're segments. Okay. So angles can be created by segments as well. That was a really good question. Knock yourself